In the winter of 1944, German soldiers were violating orders to carry a weapon that belonged to the enemy. Not because they had run out of their own weapons. The Wehrmacht's supply system was strained by the autumn of 1944, but it was not so broken that German infantrymen were going into battle unarmed. They had the Karabiner 98K, the bolt-action Mauser that had been the standard German infantry rifle since 1935, a weapon of exceptional accuracy and durability that German soldiers had been carrying from Poland to the Caucasus and back. The KAR-98K worked. German soldiers knew it. They trusted it. They were picking up M1 Garands anyway. The accounts are in the German veteran memoirs and the Allied intelligence reports. Men who had captured American rifles in the hedgerows of Normandy or the forests of the Ardennes and kept them despite the official prohibition on using enemy weapons, despite the logistical problem of finding American ammunition in a German supply system that did not stock it, despite the risk that the distinctive sound of an American rifle firing would draw friendly fire from their own side. They kept the rifles because the rifles were better. Not more accurate, the KAR-98K was accurate enough for any engagement the Eastern or Western Front required. Not more powerful, both weapons fired comparable cartridges at comparable velocities. Better in the specific way that infantry combat in 1944 made visible. The M1 Garand fired 8 rounds before it needed to be reloaded, and reloading it took approximately 3 seconds. The KAR-98K fired 1 round. Then the soldier reached up, pulled the bolt back, pushed it forward, and fired again. This took approximately 1 second, fast enough that a trained German rifleman could fire 15 rounds per minute under ideal conditions. Ideal conditions were not the conditions of a Normandy hedgerow in June 1944. In the specific chaos of close-range infantry combat, men moving, positions unclear, targets appearing and disappearing in the vegetation, the difference between 1 round and 8 rounds was not a difference of degree, it was a difference of kind. A soldier who fired 8 rounds in the time his opponent fired 1 was not participating in the same fight. He was participating in a different fight, governed by different tactical possibilities, in which the German rifleman's skill and training and courage were facing a problem that skill and training and courage could not fully compensate for. The German soldier who picked up an M1 Garand understood this empirically, from the experience of being on the wrong side of it. The story of how the M1 Garand came to exist, how the United States Army became the only major power to equip its infantry with a semi-automatic rifle before the war began, is not a story about a brilliant weapon. It is a story about a decision made in 1936 that most military professionals at the time considered premature, expensive, and probably unnecessary. The decision turned out to be the most consequential small arms procurement choice of the 20th century. It was also nearly not made at all. John Garand was a Canadian. He had been born in Saint-Remy, Quebec in 1888 and had immigrated to the United States as a young man, eventually finding work as a machinist and toolmaker in the manufacturing industry of New England. He had no formal engineering education. He had the specific intelligence of a man who understood machines from the inside, who could hold a mechanical problem in his mind and work through its solutions not on paper but in metal, at a lathe, by making things and seeing whether they worked. In 1919, he submitted a design for a semi-automatic rifle to the United States Army. The Army was not particularly interested. The war had just ended. The Springfield M1903, a bolt-action rifle based on the German Mauser design, had served adequately. The institutional momentum of a military returning to peacetime was not oriented toward expensive new procurement programs for weapons that would not be needed for years, if ever. Garand kept working. The United States Army tested semi-automatic rifle designs throughout the 1920s and early 1930s with the specific skepticism of an institution that had fought the last war with bolt-action rifles and had won. The skepticism was not unreasonable. A semi-automatic rifle was mechanically more complex than a bolt-action. More complexity meant more parts. More parts meant more opportunities for failure. A rifle that jammed in combat was worse than a rifle that fired slowly. A soldier with a jammed weapon had nothing, while a soldier with a bolt action had a weapon that required manual operation but worked reliably in the mud, the cold, and the rain that infantry combat invariably produced. The Army's testing program evaluated 17 different designs between 1920 and 1932. Most of them failed on reliability. Some failed on accuracy. Several failed on both. The institution that was supposed to adopt the winning design remained unconvinced that any of the candidates were ready for the conditions that infantry combat would impose. Garand's design survived the testing longer than most. He had been hired by the Springfield Armory in 1919, the government facility in Massachusetts responsible for small arms development, and had spent 15 years refining his concept through a series of prototypes that addressed each failure the testing program identified. The gas-operated mechanism he developed used propellant gases from the fired cartridge to cycle the action automatically, chambering the next round without any action required from the shooter. The design was reliable, more reliable, the testing showed, than most of its competitors, and it was accurate to the standards the Army required. In 1932, the Army selected Garand's design as the winner of its semi-automatic rifle competition. Then it spent 4 more years arguing about whether to actually adopt it. The arguments were institutional and financial. A semi-automatic rifle cost more to manufacture than a bolt action. The Springfield Armory's production capacity was limited, and retooling for a new design required time and investment that the Depression-era military budget did not easily accommodate. Senior officers who had commanded infantry in the First World War were not convinced that the tactical advantage of semi-automatic fire justified the procurement cost. The argument that eventually settled the question was not tactical. It was mathematical. An American infantry squad equipped with M1 Garands could deliver approximately 8 times the volume of fire of a squad equipped with bolt-action rifles, at the same level of marksmanship training. 8 times was not a marginal advantage. 8 times was a categorical difference. The difference between a defensive position that could suppress an attacking force and one that could not. Between an attacking squad that could keep the defender's head down and one that could not. Between a firefight that the American side controlled and one that it didn't. In 1936, the United States Army adopted the M1 Garand as its standard infantry rifle. No other major military in the world had done this. Germany was equipping its infantry with the Kar 98K. Britain was equipping its infantry with the Lee Enfield. Japan was equipping its infantry with the Arisaka. The Soviet Union had a semi-automatic design, the SVT-40, in development, but it would not reach mass production until 1940, and it would never fully replace the bolt-action Mosin Nagant as the standard Soviet infantry weapon. The United States was alone in deciding 6 years before Pearl Harbor that every infantryman in its army would carry a semi-automatic rifle. The decision was not universally praised at the time. Military analysts in Germany and Britain who studied the American adoption noted the cost, questioned the reliability in field conditions, and concluded that the bolt-action rifle, properly used by trained soldiers, was adequate for the infantry combat they expected to fight. They were thinking about the infantry combat of 1918. The Americans were building a rifle for the infantry combat of 1944. The difference between those two assumptions was visible, with terrible clarity, in the hedgerows of Normandy, where German soldiers who had been told their Kar 98K was adequate were picking up the rifles of men they had killed and keeping them, because the rifles of the men they had killed were better. Here is what 8 rounds without reloading meant in practice. An American infantry squad in Normandy in June 1944 consisted of 12 men, most of them carrying M1 Garands. In a standard assault, moving toward a defended position across open ground, the squad's ability to suppress the defender determined whether the assault succeeded or failed. Suppression is a specific military concept, keeping the defender's head down, making it dangerous for him to aim and fire, degrading his ability to engage the attacking force effectively. Suppression required volume of fire, not accuracy, Accuracy mattered less than the simple physical fact of rounds arriving at the defender's position frequently enough that lifting his head to aim was a decision that cost him his life. A defender who could not aim could not stop an assault. A defender who could aim, because the attacker was pausing to reload, could. The Kar 98K required its operator to perform 4 distinct physical actions between each shot. Lift the bolt handle, pull it back, push it forward, press it down. Each action took approximately a quarter of a second for a trained soldier under good conditions. Under the specific conditions of combat, adrenaline, physical exertion, fear, the fine motor degradation that stress produces, the sequence took longer. The German infantryman who emerged from his position to engage an attacking squad had, between each shot, a window during which his hands were occupied with his weapon rather than his trigger. The M1 Garand had no such window. Pull the trigger. The gas from the fired cartridge cycled the action. The next round was chambered. Pull the trigger again. 8 times, at whatever rate the shooter could manage, before the empty clip ejected with the distinctive metallic sound that became one of the most recognizable acoustic signatures of the Second World War. The sound, a sharp, ringing ping as the empty en-bloc clip was ejected from the receiver, became the subject of a myth that persisted long after the war ended. The myth held that German soldiers learned to listen for the ping, understood that it meant the American soldier was reloading, and used the 3-second interval to rush the position. The myth was plausible enough to reach the Springfield Armory during the war, where engineers investigated whether the clip could be modified to eject silently. The investigation concluded that the myth was false. The ping was audible at close range in quiet conditions. Infantry combat in Normandy was neither close range nor quiet. The sound of artillery, small arms fire, vehicle engines, and the general acoustic chaos of a contested battlefield made the ping inaudible at any distance greater than a few meters. A German soldier who was close enough to hear it was close enough to be shot by the 7 rounds that remained in the Garand before it needed reloading, or by the soldiers in the same squad who were still on their first clips. The myth survived because it was a good story. The tactical reality it described, a window of vulnerability during reload, was real for every bolt-action rifle and had been real since the beginning of the war. It was not real for the M1. What was real was the production number. Between 1936 and 1945, American factories produced 5,468,772 M1 Garand rifles. The number was not achieved by a single factory working at maximum capacity. It was achieved by the Springfield Armory and the Winchester Repeating Arms Company working simultaneously, with production methods that had been developed specifically for the M1's design. Methods that allowed the rifle to be manufactured by workers who were not specialized gunsmiths, on machinery that could be operated by people who had been trained in weeks rather than years. John Garand had not only designed a rifle, he had designed a rifle that could be built in the millions. This was not an accident. It was a design philosophy. The same philosophy that the American industrial economy had been applying to consumer goods since Henry Ford's assembly line, now applied to a weapon. Tolerances were set to allow interchangeable parts. Components were designed for machine production rather than hand fitting. A Garand built in Springfield in 1942 used parts that would fit a Garand built in New Haven in 1944 without modification. This meant that a soldier whose rifle was damaged could be rearmed from any available supply. It meant that repair required no specialized tools. It meant that the 5,468,772 rifles produced were not 5,468,772 unique objects requiring individual maintenance. They were 5,468,772 instances of the same object, interchangeable down to their smallest components. Germany was building a different kind of rifle. The German military had understood the semi-automatic rifle problem since 1941. Not in the abstract. German ordnance officers had studied the concept before the war and had concluded, with the professional confidence of men whose army had just conquered France in 6 weeks with bolt-action rifles, that the Kar 98K was sufficient. The conclusion was not unreasonable given the evidence available in 1940. German infantry had performed better than any army in the world with the weapons they had. The case for expensive procurement of a new rifle type was difficult to make when the existing rifle was winning. The Eastern Front changed the calculation. When the Wehrmacht invaded the Soviet Union in June 1941, its infantry encountered the SVT-40, the Soviet semi-automatic rifle that had been in production since 1940. The SVT-40 was not a superior weapon. It was heavier than the Kar 98K, more sensitive to dirt and cold than the German rifle, and had reliability problems that Soviet soldiers addressed by reverting to the Mosin-Nagant bolt action when the SVT-40 jammed. The weapon had genuine flaws. It also fired semi-automatically, and German infantry who faced it in the specific conditions of Eastern Front combat, close range, dense terrain, the kind of fighting where volume of fire mattered more than precision, noticed the difference between engaging a defender who could fire once and a defender who could fire without pausing. The German ordnance program that followed was driven by the specific urgency of men who had discovered a capability gap by fighting against it. 2 firms, Mauser and Walther, were tasked with developing a German semi-automatic rifle. The Mauser design, the Gewehr 41W, was tested and found inadequate. Its gas system was complex, sensitive to fouling, and prone to failure under the conditions the Eastern Front provided. Aberdeen Proving Ground, where captured examples were evaluated after the war, found that the G41's reliability was inferior to the M1 Garand in every tested condition involving mud, rain, and temperature extremes. Walther's designers looked at captured SVT-40s and took the approach that the Americans had not. They copied the gas system that worked rather than developing an original one. The result was the Gewehr 43. It entered service in October 1943, 7 years after the M1 Garand had entered American service. It was a better weapon than the G41. It was not a better weapon than the Garand. The gas system was simpler than the G41's, but more complex than the Garand's. The magazine held 10 rounds, 2 more than the Garand's 8, an advantage that the weapon's lower reliability and more difficult maintenance partially offset. The sights were adequate. The construction required skilled labor that the Walther factory's workforce could provide, but that the dispersed wartime production environment could not easily replicate. Between 1943 and 1945, Germany produced 402,713 Gewehr 43 rifles, against 5,468,772 Garands. The ratio, approximately 1 G43 for every 13 Garands, was not primarily a result of the G43's late entry into production. It was a result of the German industrial economy's inability to prioritize a new rifle type when the existing production lines were already committed to the Kar 98K, to artillery, to tank components, to aircraft engines, to the dozens of other weapons programs competing for the same factories, the same workers, and the same raw materials. The German High Command looked at 402,713 G43s and made a decision that illustrated the gap precisely. They issued 3 G43s per infantry platoon. 2 of those 3 were designated as sniper weapons and fitted with optical scopes, removed from the general infantry role entirely. 1 G43 per platoon was available as a standard infantry semi-automatic rifle. 1 rifle, against the 12 Garands that an American infantry platoon carried as its standard weapon. German soldiers who encountered this arithmetic in combat did what soldiers do when their equipment is outmatched. They adapted. They developed tactics that used the Kar 98K's accuracy at longer ranges where the Garand's volume advantage was less decisive. They used the MG42 machine gun, a weapon of extraordinary rate of fire that partially compensated for the bolt-action infantry rifle at the squad level. They fought with skill and training that was, by every metric, the equal of their American opponents. And when they got the chance, they picked up Garands. The German soldier who picked up an M1 Garand in Normandy faced an immediate practical problem. The rifle worked. He knew how to operate it. The basic mechanics of a semi-automatic rifle were not difficult to learn, and the M1's design was straightforward enough that a soldier who had never handled one could figure out the loading and firing sequence in minutes. The weapon was reliable in a way that the G43, when he had one, was not always reliable. The 8-round clip loaded cleanly, the action cycled smoothly, and the rifle sat in the shoulder with a balance that the Kar 98K's longer, heavier profile did not match in close-range fighting. The problem was ammunition. The M1 Garand fired the .30-06 Springfield cartridge, a round that had been the American military's standard rifle ammunition since 1906. It was not a round that the German military manufactured, stored, or distributed through its supply system. A German soldier who carried an M1 Garand was carrying a weapon that depended on ammunition he could only obtain by taking it from dead or captured Americans. In the specific conditions of the Normandy campaign, where the front was fluid enough that both sides were overrunning each other's positions regularly, this was not impossible. American ammunition dumps were captured, American soldiers were killed, and their ammunition was taken. A German soldier in the right position at the right moment could accumulate enough .30-06 to sustain an M1 Garand for days of combat. He was still operating outside the German supply system entirely. The Wehrmacht's logistics, the system of ammunition distribution that moved rounds from factories in Germany to soldiers at the front, was calibrated for 7.92 by 57 mm Mauser, the cartridge that the KAR-98K, the MG34, and the MG42 all fired. This calibration was both the system's strength and its constraint. A German soldier with a KAR-98K could always expect resupply, because every German unit carried Mauser ammunition, and every German supply chain distributed it. A German soldier with an M1 Garand was dependent on what he could find, and what he could find ran out. The German military's official position on captured weapons was clear. They were to be used only in emergencies and not retained for continued service. The prohibition existed precisely because of the logistics problem. A soldier who relied on a captured weapon was a soldier who might find himself without ammunition at a critical moment, because the system that supplied his unit did not supply his rifle. The prohibition was regularly violated. The accounts in German veteran memoirs are consistent on this point. Men who had used captured Garands described doing so not because they lacked their own weapons, but because the Garand's performance in close combat was preferable. The volume of fire, the absence of a manual reloading cycle, the specific advantage of 8 rounds against 1. These were things that infantry soldiers understood empirically, from the experience of combat, without needing a staff study to quantify them. The violation of the prohibition also had a second consequence that the accounts describe with dark humor. The distinctive sound of the M1 Garand, not the ping of the ejected clip, which was inaudible at distance, but the specific acoustic signature of the semi-automatic action cycling, the pattern of fire without the pause between shots that the bolt action produced, was recognizable to trained ears as American fire. A German soldier firing a Garand at night, in a position where his own side could hear him, risked drawing fire from German units who heard American fire and responded accordingly. The sound of the weapon that worked best was the sound that could get you killed by your own army. The MG42 was Germany's answer to the volume problem. The machine gun that the Wehrmacht had developed in 1942 fired at a rate of 1,200 rounds per minute, so fast that individual shots were inaudible as separate sounds, producing instead a tearing, continuous roar that American soldiers called Hitler's buzzsaw, and that was unlike any weapon sound they had encountered in training. At that rate of fire, an MG42 crew could put more rounds downrange in a second than an American squad could fire in a minute. The MG42 was the tactical compensation for the KAR-98K's single-shot limitation. German infantry doctrine had been built around this compensation since the beginning of the war. Where American doctrine centered the squad's firepower in the semi-automatic rifles carried by every man, German doctrine centered the squad's firepower in the MG42. The machine gun was the primary weapon, and the rifleman's role was to protect the gun crew and carry ammunition. The doctrine worked. German defensive positions built around an MG-42 were extraordinarily difficult to assault, and the weapon's influence on Allied infantry tactics was visible in every operation from North Africa to the Rhine. The compensation had a limit. An MG-42 required a crew, a gunner, and an assistant gunner at minimum, with additional men to carry the ammunition that the weapon's rate of fire consumed. It required a fixed or semi-fixed position to be effective. The weapon's weight and the ammunition load it needed made it difficult to move and fire simultaneously in the way that a rifleman could. And it required the enemy to come to it, or at least to present itself in the open ground where the MG-42's range and rate of fire were decisive. In the bocage of Normandy, where the terrain broke the battlefield into enclosed fields, separated by earthen banks dense with vegetation, where engagement ranges were measured in tens of meters rather than hundreds, where infantry moved through lanes so narrow that a machine gun's field of fire was blocked before it reached the distance at which it was most effective, the MG-42's advantages were reduced, and the Garand's advantages were amplified. At 20 meters in a hedgerow, the difference between 8 rounds and 1 was not compensated by a machine gun that was positioned 50 meters away. American infantry commanders in Normandy documented this in their after-action reports, with the specific precision of men who had learned something important and wanted it recorded. The reports described the effectiveness of the Garand's volume of fire in close terrain, the difficulty of German defensive positions that relied on the MG-42 in environments where the gun's field of fire was restricted, and the tactical flexibility that a squad of semi-automatic riflemen possessed that a squad of bolt-action riflemen did not. The reports went up the chain. They were read. They confirmed what the procurement decision of 1936 had been based on, that in the infantry combat that the war was actually producing, volume of fire at the squad level was decisive in ways that accuracy alone was not. Patton read some of these reports. He had been reading them since North Africa. His assessment, delivered in the specific, unqualified language that Patton used when he had reached a conclusion, was that the M1 Garand was the greatest battle implement ever devised. Patton was not given to excessive praise of equipment. He was given to precise assessment of what worked. The German soldier who picked up an M1 Garand in a Normandy hedgerow and kept it, despite the logistics problem and the friendly fire risk and the official prohibition, had reached the same assessment by a different route. He had not read the after-action reports. He had been in the hedgerow. He knew what the rifle did. What it did was fire 8 times without stopping. In a war decided by what happened in the 2 seconds between one man's first shot and his next, 8 was the number that mattered. The number that explains the Garand story is not 5,468,772. It is $85. That was the cost of a Thompson submachine gun in 1942, the weapon that American infantry had been using for close-range combat since the beginning of the war. The Thompson was effective. It fired .45 caliber rounds at a rate that suppressed close-range targets efficiently, and it had a reputation for reliability that American soldiers trusted. It was also heavy, expensive to manufacture, and required skilled labor to produce at the tolerances its mechanism demanded. The Army looked at $85 per Thompson and began looking for alternatives. The M3 submachine gun, the weapon that American soldiers called the grease gun for its resemblance to the tool used to lubricate automobile fittings, was the answer. It was designed by George Hyde, an engineer working for General Motors' Inland Division, and it cost $15 to manufacture. Not $15 as an approximation, $15 as the specific unit cost that the Army's procurement office had set as the target, and that the Inland Division had met by designing a weapon from stamped metal components that required no precision machining and could be assembled by workers with minimal training. The grease gun looked like what it was, a weapon built to a price. The welding on its receiver was rough. The fit of its components was functional rather than fine. A German engineer who examined one would have been, by all accounts, appalled at the manufacturing standards. The German engineer would also have been wrong about what the manufacturing standards meant. The grease gun fired .45 caliber rounds from a 30-round magazine at a rate that was entirely adequate for the close-range combat it was designed for. It was lighter than the Thompson. It was easier to store. The collapsible stock folded against the receiver, making it compact enough to fit inside a tank, where the Thompson's bulk was a problem. It met the Army's requirement that 90% of its rounds hit a 6-foot by 6-foot target at 50 yards, a standard that reflected the reality that submachine guns were not precision instruments and did not need to be. It was manufactured by an automobile company. This was not incidental. The American war economy's most powerful single asset was the automobile industry. The manufacturing infrastructure, the workforce, the tooling, and the management expertise that had been built over 4 decades to produce cars in the millions, and that was now producing weapons instead. General Motors had been building military trucks since 1942. Its inland division was now building submachine guns. The transition required retooling and retraining, but the underlying capability, mass production of metal components to functional tolerances at industrial scale, transferred directly from civilian to military production. Germany did not have an equivalent transfer. The German automobile industry in 1944 was smaller than the American, less automated, and more heavily committed to military vehicle production that could not be easily redirected. The precision manufacturing culture that had made German weapons, including the MP-40 submachine gun, technically superior to their American counterparts, was also the culture that made them slower to produce and more dependent on skilled labor that the war was consuming faster than it could be replaced. The MP-40 cost approximately 4 times what the grease gun cost to manufacture. It was a better weapon by the standards of a gunsmith. It was the wrong weapon by the standards of a war. The German soldier who preferred a captured Garand to his Kar 98K was making a rational choice. He was also making a choice that his army's industrial system had made impossible to institutionalize. This is the distinction that the story of the M1 Garand ultimately turns on. The rifle's tactical superiority was real and recognized by American commanders who documented it, by German soldiers who demonstrated it by carrying captured examples at personal risk, by the post-war analysis that consistently rated it the finest infantry rifle of the conflict. The superiority was not in dispute. What was in dispute, what the German army's inability to field a comparable weapon in comparable numbers made visible, was whether tactical superiority in a weapon could be achieved and sustained at the scale that industrial war required. Germany had answered this question across multiple weapon systems with the same result. The Tiger tank was tactically superior to the Sherman. Germany produced 1,347 Tigers. America produced 49,000 Shermans. The Panther was tactically superior to the Sherman's standard 75mm armed variant. Germany produced 6,000 Panthers. The FW-190 was tactically superior to early Allied fighters. Germany produced 20,000 FW-190s. America produced 15,000 P-51 Mustangs and 12,000 P-47 Thunderbolts in the same period. The G-43 was tactically competitive with the Garand in the specific engagements where German soldiers could use it. Germany produced 402,713 G-43s. America produced 5,468,772 Garands. The pattern was not a coincidence. It was the expression of a fundamental difference between two industrial economies. One that had been optimized for the precision production of technically excellent objects in limited quantities, and one that had been optimized for the mass production of functionally adequate objects in unlimited quantities. John Garand had understood this without being able to articulate it as an economic principle. He had designed a rifle that could be built in the millions, not because he was thinking about economic theory, but because he was a machinist who knew what machine production required and had designed accordingly. The interchangeable parts, the tolerances set for machine manufacture rather than hand fitting, the simplicity of the operating mechanism, these were the choices of a man who understood factories from the inside. The The Springfield Armory that hired him understood it too, in the specific institutional way of an organization that had been manufacturing weapons since 1794 and had absorbed, over those 150 years, the lessons of American industrial development that Henry Ford had systematized and that the war economy had now applied at a scale that no previous conflict had required. A German soldier in the Ardennes in December 1944, carrying a captured Garand with 3 magazines of scavenged American ammunition, was at the end of a chain that ran from a machinist's workshop in Springfield, Massachusetts, through an assembly line that had been producing 600 rifles per day since 1941, to the specific field in France or Belgium where he had found the rifle lying beside a dead American. He was carrying the product of a system that his own system could not replicate. Not because German engineers were less capable. The G43 was a competent design, and the engineers who produced it were working under constraints: industrial capacity, material shortages, competing program priorities, that American designers did not face. Not because German soldiers were less skilled. The men who fought in the Ardennes were among the most experienced soldiers in the German army, and they used the weapons they had with a tactical sophistication that the after-action reports of the American units opposing them consistently acknowledged. Because the war had become, by 1944, a contest between industrial systems rather than between armies, and the industrial system that had decided in 1936 to equip every infantryman with a semi-automatic rifle, and had then built 5,468,772 of them, was the system that had won that contest before the fighting started. The German soldier knew this. He was carrying the evidence. John Garand never received a patent royalty for the rifle that bore his name. He had assigned his patent rights to the United States government when he joined the Springfield Armory in 1919, a standard condition of government employment that meant the 5,468,772 rifles produced under his design generated no personal income for him beyond his government salary. He was not a wealthy man. He worked at the Springfield Armory until his retirement in 1953, earning the salary of a government engineer, while the rifle he had spent 15 years developing became the standard infantry weapon of the most powerful army in the world. Congress periodically considered compensating him. Bills were introduced. Hearings were held. The amounts discussed ranged from $100,000 to $1 million, figures that reflected, depending on who was calculating, either the specific value of the patent rights he had surrendered or the broader value of what the rifle had contributed to the war's outcome. None of the bills passed. Garand accepted this with the specific equanimity of a man who had spent his career in a government institution and understood the relationship between individual contribution and institutional reward. He gave interviews. He attended ceremonies. He held his rifle when photographers asked him to. He described the design decisions he had made in the 1920s and 1930s with the precision of a man who remembered exactly what he had been trying to solve and why each solution had taken the form it had. He died in 1974 at the age of 86. The rifle outlasted him by decades. M1 Garands were in American service through the Korean War. They were exported to the armies of post-war West Germany, Italy, and Japan. The countries the rifle had helped defeat, now equipped with the weapon that had defeated them. They appeared in the hands of irregular forces in conflicts through the 1960s and 1970s. The last American military units carrying M1 Garands as standard equipment retired them in the early 1970s, replaced by the M14 and then the M16, weapons whose design lineage ran directly through the lessons the Garand had established about what a semi-automatic infantry rifle needed to do. The German army that had faced the Garand in Normandy was re-equipped after the war with American weapons, including M1 Garands, which the Bundeswehr carried as its standard rifle until the 1960s. The men who had picked up captured Garands in the hedgerows and carried them against official orders were, a decade later, being issued the same rifle by the government of the country that had built it. The irony was precise and complete. The Gewehr 43 did not outlast the war that produced it. Production ended in 1945 when the factories were overrun or destroyed. The 402,713 rifles that had been built were captured, surrendered, or abandoned. Some ended up in collections. Most ended up in the systematic weapons destruction that the Allied occupation authorities conducted in the years after Germany's surrender. The rifle that Germany had needed and could not produce in sufficient numbers disappeared from service within months of the war's end. The rifle that Germany's soldiers had preferred to carry, in violation of orders, at personal risk, with the logistical constraint of ammunition that their own supply system did not provide, continued in service for 30 years. The preference was not sentimental, it was professional. The M1 Garand was a better rifle for the war that was actually fought, not the war of 1918 that the bolt-actions advocates had been preparing for, but the war of hedgerows and island landings and urban combat, where the man who could fire 8 times without stopping was a different order of threat from the man who could fire once. Garand had understood this in 1919, when he submitted his first design to an army that was not interested. The army had taken 17 years to agree with him. The Germans had never agreed. They had understood the problem. The SVT-40 had made it impossible to ignore, but they had not been able to solve it at the scale the war required. The solution was not the rifle. The solution was the factory, and the factory was America. The verdict on the M1 Garand is in the number, not 5,468,772, though that number tells its own story. The verdict is in the ratio, 1 G43 for every 13 Garands. 1 German semi-automatic rifle for every 13 American ones. Germany understood the problem. Germany built a solution. Germany could not build enough of the solution to matter. This is the specific failure that the Garand story illuminates. Not a failure of engineering, not a failure of courage, not a failure of the individual soldiers who carried inferior weapons and used them with skill that their opponents consistently acknowledged. A failure of scale. The failure of an industrial economy that had been built for precision and could not convert to volume in the time the war allowed. The American economy had been built for volume since Henry Ford's assembly line. The decision to apply that economy to a semi-automatic rifle, made in 1936, before the war, before Pearl Harbor, before anyone knew what the hedgerows of Normandy would require, was not a decision made with the war in mind. It was a decision made with the specific logic of a military that had looked at the infantry combat it expected to fight and had asked, "What rifle can we build 5 million of?" The answer was the Garand. The German military had asked a different question. What is the best rifle we can build? The answer to that question, by the standards of gunsmithing and ballistics, was not the KAR-98K. The Germans knew this by 1941. They built the G43 to answer it. They built 402,713 of them. The wrong question, answered correctly, at insufficient scale. The right question, answered adequately, at 5.5 million. The German soldier who carried a captured Garand in the Ardennes in December 1944 was not making a statement about American manufacturing philosophy. He was making a decision about survival. He had found a rifle that gave him 8 shots where his own rifle gave him 1, and he had kept it despite the prohibition, despite the logistics problem, despite the friendly fire risk. He had made the same calculation that the United States Army had made in 1936. 8 is better than 1. The calculation was simple. The execution, building 5,468,772 rifles that embodied it, delivering them to infantrymen across 2 ocean theaters, maintaining them in the field with interchangeable parts that any armorer could replace without specialized tools, was not simple. It was the work of an industrial economy that had been preparing for it, without knowing it was preparing, for 40 years. John Garand did not get rich from the rifle. He did not receive the congressional compensation that was discussed and never passed. He returned to his government salary and his workbench at Springfield and spent the post-war years answering the questions of historians and journalists who wanted to understand how the rifle had been made. His answer was always the same. He had been trying to solve a specific problem. The problem was how to let a soldier fire more than once without stopping. The solution was the gas-operated semi-automatic action. Everything else, the en-bloc clip, the 8-round capacity, the specific dimensions of the receiver, followed from the solution. He had solved the problem in 1919. The Army had agreed with him in 1936. The war had confirmed them both between 1941 and 1945. The German soldiers who agreed with him did so in the hedgerows of Normandy and the forests of the Ardennes, by picking up the evidence and carrying it home. They were the last people who needed to be convinced. They had been convinced by the rifle itself, 8 rounds at a time.